first activity 2, using a formula for multiple trials. And our formula is this one. Great formula. The whole purpose of this activity, in fact, if you could skip activity 1 and just get right to this, well, good for you. But I'm glad you were there for activity 1 when you were. Let's calculate each probability. You're rolling a number cube with 4 red faces and 2 blue faces. And just while we're here, the probability of red would then be 4 out of 6. Because there are 4 faces and there are 6 total. The probability of blue, I'm not automatically going to say 2 out of 6 as my answer. I'm going to get there in a step. 1, take away 4/6. Because if you're not rolling a red on the die that you're tossing, then the only other option that you have available for this is a blue. So then take away the probability of red from the 100% total, and you wind up with 2/6, because that's the probability of getting the other shape. When we have this dichotomy, good word for you, where you have one choice and then the other, then that allows us to think about how 100% takeaway is the probability of the other event happening. Also, I'd like you to note 5 choose 4 is the same as 5 choose 1. And if you don't believe me, we have a calculator for that. NCR, 5 choose 1. NCR, 5 choose 4. Okay, so we're going to be able to use that as a shortcut. In fact, I know that right now. The probability of rolling 4 reds and 1 blue when you roll a number cube 5 times. So I wrote it all out. Probability of 4 reds and 1 blue. There's 5 ways that could happen. The probability of rolling a red is 4/6, and that's to the power of 4. Reminder, our formula, whatever these numbers are, this is where they go. Okay? Times 2/3 to the first power. Your exponents should add up to 5. This number out here should be, well, no, this number out here should be the answer of 5 choose 4. But the 5 and the 4 become our exponents and the calculation for that last one. Now it's just a calculator problem. So here we go. Calculator, 5, because NCR, 5 choose 4, is 5, times 4/6 to the power of 4, then bump to the right, and then go parentheses, 1 divided by 3. No, what am I doing? 2 divided by 6. Why did I write 2/3 there? I just wrote 2/3. What is my brain thinking? This should be a 6 right here. There we go. Probability of blue. And then this is to the second power. Enter. I am frustrated. It keeps giving me an 80 over 729 large fraction. So I'm going to go Control Enter, and I'm going to get my decimal, which is 0.10974. You know, the number after the 9, the 3 is a 9, so then the 9 makes the 3 round up. If I right now multiply by 100, it'll tell me the percentage. I hope you were able to see, though, it was 10.9%. 10.974%. With that in mind, and with everything that I showed you in the previous activity number 1, why don't you go calculate B and C? And I'll show you, and even number 2. Finish the rest of this page. I feel like I have less I need to explain to you now because it's all about the formula. Here we go. 6 choose 3. At this moment, I'm going to be talking to myself and muttering out loud so you can kind of hear what I'm thinking out loud, but you don't have to pay attention to any of it if you know what I'm doing before I do it. So maybe pause and skip to the end. Time to mutter. NCR 6 choose 3 times the probability of red, 4/6 to the power of 3, times the probability of blue, 2/6 to the power of 3, and I get 160 out of 729, which is times 100, Control Enter, 21.95%. Cool. Okay. Rolling 1 red and 6 blues when you roll the number cube 7 times. So 7, choose 1. Probability 1 red, 6 blue, so 7 choose 1. That happens 7 ways. Probability of a red, so that would be 4/6 to the first power, and a blue, 2/6 to the 6th power. And then we're going to go, can I copy paste? Yes, copy paste. So I want here 7 choose 1. I want this to be the first power exponent. And then I want this to be the 6th power. Lock it in. 14 out of 2187. So then I want the percentage for that. So I'm going to times by 100, and I'm going to do the decimal to get, wait. Oh, that's so small. Okay, so it is a percentage, 0.64%. Yeah, because this one is a really small decimal. Okay, yep. Okay, everything's on the screen? Good, all right. I mean, if you're, okay, I'm back in right here for a minute just to like talk to you if you're still listening. I'm talking to myself because I'm trying to think out loud what I'm doing. And if you hear me say what I'm doing, awesome, love it. Maybe you're processing as well. But put it on mute, skip forward 30 seconds. I will explain it for a minute here if you are catching this in the moment. Rolling 1 red and rolling 6 blue. That's what I put in the parentheses, and I put the P for probability in front of that. The probability of rolling 1 red and 6 blues. So then that's 7 total times that I'm rolling the die. And I want to put the probability 1 for the probability of rolling a red. If I'd flip this around, it would still be fine. It would still work because red would still have a 1 exponent while blue would have the 6 exponent. 7 minus 1. So all said and done, this is just straight out of the calculator. In question 2, same idea. Rolling 3 reds and 7 blues, rolling the number cube 10 times. 10 choose 3. Probability of red, 3 times. Probability of blue, 10 minus 3, 7 times. Calculator time. I need this to go here. I need this to go like so. Spot it. Okay. So we have, let's go ahead and clear this. Menu 1, 5. And then we'll go all from the calculator. Menu 5, 3. 10, choose 3. Close it. Parentheses. Fraction 4/6. Outside the fraction to the power of 3. And then to the front times fraction 2/6 outside to the power of 7. Then right now, I'm going to multiply by 100 so I can get the percentage, and I'm going to control enter to get 1.63%. Yep. Okay, let me see if I can change this to, yeah, this might make it be also a little bit bigger for the last one. So rolling 3 reds and 4 blues when a number cube is rolled 7 times. So I'm going to go up. I'm going to press enter to bring it down, and I'm going to edit it. So I'm going to go 7 here, and then I'm going to go, that's a 3. This needs to be a 4. And then times it by 100 to turn that fraction into a percentage. Control enter. 12.80%. That was it. Maybe you're here. Maybe you skipped all the way to the end. I'm going to leave the entire calculation on there. I want to show that I'm using combinations, the probabilities, the exponents. I'm multiplying by a percent. And then notice I'm doing control enter so that I can get the decimal and not a fraction. Because if I don't do that, I don't want that number. I don't want a fraction. I want the decimal. 12.80%. It's good to also with probabilities reported in percentages because probabilities are like a likelihood and percentages are a likelihood. So put your answer in percent, 2 decimals at the end. Thank you for watching this video. This has been page 888. On page 889, we continue the conversation, but you've got the mathematics. You've got it down. Practice it. You've got this, and I'll see you in the next episode.